Alright, this lesson is about end behavior, degree, leading coefficient, classifying, and evaluating polynomials. A lot is packed into this little lesson. Standard form. The key thing about standard form is it should be in descending exponential order. So, highest first. So this one should be 7x to the third power. Okay, and then plus 4x squared. Alright, because that's the next exponent. And then minus 5x. And finally plus 6. Okay, descending exponent order, that's standard form. Now, the degree is going to be the highest exponent. So it'll be the exponent of the first term if it's in standard form. So the degree is 3. The leading coefficient is 7. Once you put it in standard form, the leading coefficient is going to be right in the front. The constant term is the term that doesn't have any variable on it. So in this case, the constant term is 6. What type of polynomial is it? Alright, I want that 2-word classification. Because of the degree being 3, this is a cubic something. The rest of the classification has to do with the number of terms. If there were only one term, that would be a monomial. If there were 2 terms, it would be a binomial. If there were 3 terms, like this, that would be a trinomial. But anything over 3, we just go with polynomial. So we will call this a cubic polynomial. Describe the end behavior in words and using arrow notation. Well, because it is cubic and because the leading coefficient is positive, cubic functions have end behavior like capital N's. Alright, so the end behavior, if I did a quick sketch of it, this would be the sketch I would draw. This being the positive version of it. And we will go with the positive version because the leading coefficient is positive 7. So with this picture in the back of our minds, we will say on the left it falls and on the right it rises. Bam! Alright, on the left it falls, on the right it rises. Using arrow notation, it would be like this. Yeah, so since on the left it falls, on the right it rises, that means as x approaches negative infinity, f of x approaches negative infinity, and as we go towards positive infinity, it goes to positive infinity. The key part is on the left it falls, thus negative infinity. On the right it rises, thus the positive infinity. This first part never changes. This just means left and right. Okay. Evaluate using direct substitution. Well, direct substitution is what you're doing when you take this negative 3 and you substitute it in for all the x's. So looking back at the original polynomial, if I can squeeze it in the picture, this is the function. So direct substitution would look like this. 7, alright, 7x to the third power, so 7 times negative 3 to the third power plus 4 times negative 3 squared minus 5x, so minus 5 times negative 3 plus 6. Okay, this is direct substitution. And the easiest way to do that, of course, is to use your handy dandy TI-30XS multiview. Watch me work, people. So 7 times negative 3. Use the caret for the third power. Alright, plus 4 times negative 3 squared minus 5 times negative 3 plus 6. Boom. negative 132. Okay, that is how you do that by direct substitution. Now, let's do it by synthetic substitution, and we better get the same answer. Okay, so synthetic substitution, you start off with a box. Okay, and inside that box, you put the number that you're going to be plugging in. Alright, so negative 3. Alright, then you put all your coefficients, making sure that you're not missing any. If any are missing, we'll need zeros as placeholders, but here I have 3, 2, 1, 0, so nothing seems to be missing. Third power, second power, first power, 0 power. Okay, so nothing's missing, so my coefficients are 7, 4, negative 5, and positive 6. Alright, skip a line, leave a space. And here at the end, we're going to need another box, because this is where the answer will be. So here comes the procedure. The first number, the first coefficient, you just drop it down. Now you multiply and you combine. So 7 times negative 3 is negative 21. Alright, 4 and negative 21 make negative 17. Negative 17 times negative 3, that's positive 51. Okay, you put it in the next available spot. So negative 5 and positive 51, that's going to be positive 46. So now I've got positive 46 times negative 3, and you put it here. And that is negative 138. And finally, you combine these. So positive 6 and negative 138 make negative 132. So there you go. Negative 132 is your final answer. Notice it's the same thing. Alright, you have to know how to do it both ways. You can't go, oh, I just like direct substitution, I'm just going to do that. No, if I say synthetic, you better do synthetic. Oh, plus, this is going to be key to other things we're going to do later. So trust me, you're gonna need to know synthetic anyway. Alrighty then. Alright, look at number 2. Number 2 has nothing to do with this graph. This graph goes with number 3. Is this a polynomial function? This is just a yes or no question. And the answer is yes. Okay. The exponents, this is like x to the 1 power, this is the 4th power. The exponents are fine. You're not allowed to have negative exponents. You can't have fractional exponents. But the coefficients, like 0.07 is a coefficient. It's allowed to be any real number. So as long as it's not imaginary, it can be as ugly as it wants to be. So 0.07, that's fine. 3/5, that's fine. Square root of 11, these ugly coefficients are all fine. It is a polynomial function. Okay? You can't have any x's in the denominator either, but that's not happening, so we're good. Now look at number 3. Number 3, function h refers to this graph. Describe the end behavior in words and in arrow notation. Well, on the left it falls, and on the right it falls. Bam! Like this. So how would I translate this into arrow notation? Kabam! On the left it falls, and on the right it falls. So negative infinity and another negative infinity. Alright, again, this first part never changes. This just means on the left, and this means on the right. Falls, falls. Okay. What, if anything, can you tell about the degree of this? What can you tell me about the degree? Alright, I'll give you a hint. You should be able to tell me whether or not it's even or odd. So which is it? Alright, I'm hoping that you can tell that this is even degree. Alright, it's even degree. I can tell because the end behavior, both sides are pointing in the same direction. Alright, this is behaving just like an upside down parabola would. Alright, and you know that a parabola is definitely even degree because that's squared. Okay, so this is, the end behavior is working like a parabola, so that means it is even like a parabola. Okay, also, what if anything can you tell about the leading coefficient? Well, just like this would be the same end behavior as an upside down parabola, so that tells us that this is the negative version as opposed to the positive version. So the leading coefficient is negative because both arms are facing downward. If both arms were facing upward, that would be a positive leading coefficient. So what, if anything, can you tell about the leading coefficient? It is negative. Okay. Alright. Number 4. What type of function is this? Alright, I'm looking for that two-word classification like cubic binomial, that type of thing. Well, first we look at the degree and we say a name for that. This is 4th degree. Alright, so degree 1 is linear, degree 2 is quadratic, degree 3 is cubic, degree 4 is what? What's that? Degree 4 is quartic. So this is a quartic something. A quartic what? Well, this is a 3-piece. So that makes this a quartic, I say 3-piece. This has 3 terms. Let me use the proper terminology. 3 terms, so this is a quartic trinomial. Quartic trinomial. Alright, 4th degree, 3 terms. Alright, describe the end behavior of this. Now, there's no picture this time, but based on the fact that it's an even degree, and we know that all even degree end behavior works the same. So you should be picturing a little sketch in the back of your mind. Okay? And if you see even degree, picture a parabola. So am I going to sketch an upward facing parabola or a downward facing parabola for this? This will have the same end behavior as an upward facing parabola. Alright, parabolas are even degree like this, so I know it'll work like a parabola. But because this 2 is positive leading coefficient lets me know to go with the up version. If this were negative 2, I would have done it upside down. Now, with this picture in mind, it's easy to do the end behavior. In words, we'd say on the left it rises, and on the right it rises. Bam! Like this. Alright, now how about that arrow notation? Rises, rises. What's that going to look like? Rises, rises. Positive infinity, positive infinity. You don't actually have to put the plus for the positive infinity. You could just put infinity if you want to. I just felt like emphasizing it for some reason. Alright, moving on. Number 5. Okay, evaluate this guy using synthetic substitution. Let's see, is anything missing? 5, 4, uh-oh. The cubic term is missing. Alert, alert, warning. The cubic term is missing. So we're going to have to treat this missing cubic term like it's a 0 x to the 3rd power. So when we do our coefficients, there'll be a 0 right here. Alright, that's the one thing to watch out for when you're doing synthetic. So you make your box, and I'll have my negative 3 in there. Now here come my coefficients. Negative 2, -3, 0, 4, 2, -10. Alright, leave a space. Make another box at the end. Alright, first number you just bring it down. Now I multiply and add. So -2 times -3, that is +6. Alright, -3 plus 6 is +3. 3 times -3 is -9. 0 and -9 make -9. -9 and -3, -9 times -3 make +27. 27 and 4 make 31. 31 times -3 is -93. Okay, -93 and +2 make -91. -91 times -3 273. Alright, so then we have, so we put the 273 right here. Of course, -10 and 273 together make 263. Alright, and so j of -3 equals 263. Good times. Describe the end behavior using words and arrow notation. Again, they did not give us a picture, but we can do a sketch, an end behavior sketch that will get the job done. You need to focus on two things: the degree and the fact that it's a negative leading coefficient. All odd degree polynomials share the same end behavior. We have memorized the end behavior of a cubic, which is odd. So a cubic, when it's positive, it looks like this. A cubic, when it's negative, looks like this. For me, it's easy to remember because the positive cubic is like a right side up n, capital N. So a negative cubic would be like an upside down n, like this. Now, like I said, because we're dealing with a -2, a negative leading coefficient, that's why we are going to go with the upside down n version. Okay, so in words, this end behavior is: on the left it rises, on the right it falls. Like this. On the left it rises, on the right it falls. Just use this little sketch. Alright, in arrow notation, okay, on the left it rises, so that first one on the left it rises, so positive infinity, but on the right it falls, so that means this second one here should be negative infinity, for it falls. Okay, so there's your arrow notation. Okay, number 6. State the type of each polynomial below. So we're going to classify using the two-word classification, like cubic, trinomial, or whatever. So this one, degree 5. Okay, what is the word for degree 5? Quintic. Quintic. Alright, so because of the 5, this is a quintic. A quintic something. Alright, how many terms do we have here? 2. So this is a quintic binomial. Okay, a quintic binomial. Alright, what about this next one? This is not in standard form, but the degree is 2. Alright, even though it's out of order, look for the highest exponent. So this is degree 2. So degree 2, what's the word for degree 2? Degree 2 is quadratic. Quadratic. So this is a quadratic something. A quadratic what? I've got 1, 2, 3 terms. So this is a quadratic trinomial. Okay, quadratic trinomial. And finally this. There are no x's at all. That means this is a constant. When it's just a number, no variables, that is a constant. So constant. And it can only be a monomial. A constant monomial, one term. Okay. Make up a quartic binomial. Well, quartic is degree 4. Okay, so I'm looking for like x to the 4th power. And a binomial is 2 terms. So let's see, quartic. So it's got to have x to the 4th power in it, and it's got to have 2 terms. So I'll just say x to the 4th power plus x. This would be a quartic binomial. Alright, but it doesn't matter. Alright, I could put a 2 in front of here. As long as I have x to the 4th power and it's 2 terms, that'll be a quartic binomial. Now, draw a function with the following end behavior. Alright, on the left it falls, and on the right it rises. Alright, this means on the left and this means on the right. So we need one that on the left it falls and on the right it rises. So we could use your classic cubic form for that. Okay, like this. Okay, on the left it falls, on the right it rises. So this would match. Alright? Make up a function with degree higher than 3 that has the above end behavior. Okay? Well, this would be, the one I drew, this would be this would be degree 3. This would be like a cubic. So, if it's going to have the same end behavior, it's going to have to be odd like a cubic, but higher than degree 3 because that's what it says. So we could do x to the 5th power or x to the 7th power, anything odd. I think I'll go with x to the 7th power, but the main thing is that it's got to be odd. So let's see, f of x, and I'm going to put an x to the 7th power in here. I'm going to give it a coefficient just for the heck of it. Let's say I could just put I'm going to put a 2 here. So 2x to the 7th power. Anything else I write is just for fun. Alright, this is the key right here. In fact, look, this is the key. Okay, it has to be a positive x to the, and it has to be an odd power. But the rest of it is up to you. Alright, so I could do a 2 x to the 7th power plus 4x minus 6 or whatever. Doesn't matter whatever else I want to put on it. Alright? But this would have the same end behavior as this because it's positive and odd degree. Alright, that is it for the classwork. Hope this was helpful.